Today we will start with a new unit, that is Unit 3, Polymer Chemistry. So what are polymers? Polymers are the large molecules composed of repeated chemical units. The smallest repeating unit is called monomers. Now, the word polymer is derived from Greek word poly, many, and mer means part. It is generally described in terms of single repeated units. For example, here I have taken ethylene that is converted into polyethylene by the process of polymerization. Polymers is a macromolecules built up by linking together of large number of smaller molecules called monomers. For example, polythene is a polymer formed by linking together of large number of ethylene molecules. Now, second example is styrene that is converted into polystyrene by the process of polymerization. Now we will see what is polymerization. Polymerization is a process by which polymers are formed. This polymerization process is divided into three types, that is addition polymerization or chain polymerization. Second is condensation polymerization or step growth polymerization, and third is copolymerization. Now, next topic is degree of polymerization. This degree of polymerization is also shown by dP. The number of repeating unit, that is N, in a polymer chain is called degree of polymerization. For example, if I have taken 100 molecules of clean polymer, ethylene molecules to give the polymer chain, the dP of the ethylene is 100. All the polymers are macromolecules, but all the macromolecules are not polymers. Now we will see the next is condensation polymers. This condensation polymerization is also known as step polymerization. Whenever this condensation polymerization takes place, the water will come out as a byproduct. Now we will see the example of condensation polymerization is the preparation of nylon 6,6. Now second is addition or chain polymerization. Here in this process, the monomer molecules will add to each other in a chain reaction and it will form a polymer, that is known as addition polymerization, and no byproduct is formed in this process. Now the polymer has the same chemical composition as that of the monomer we have. The molecular weight of polymer is the exact multiple of the monomer. These are the property of addition polymerization. Now comes to next topic, that is copolymerization. It is a polymerization of two or more species high molecular weight compound obtained by copolymerization are called copolymer. For example, bakelite and styrene are copolymers to give a GRS rubber, that is styrene butadiene rubber. Now next topic is we have taken the polymer. For example, nylon 6,6, it is a type of polymer, a polyamide. It is commonly known as nylon. The IUPAC name of nylon 6,6 is hexane 1,6-diamine. The simple molecular formula is on the screen, it is written over here. Now we will see the structure also of nylon 6,6. So how it is prepared, we will see with the help of this reaction. Adipic acid will react with hexamethylene diamine and it will form nylon 6,6. Now we will see the bakelite. It is another example of polymer. So when we see this bakelite, now we will see the preparation. Whenever phenol will react with formaldehyde, then the reaction mixture is there and a basic medium is there and condensation product will form, and the polymer which is formed, that is known as bakelite, it is known as thermosetting polymers. We cannot deny the presence of polymer in our lives. We are surrounded by objects, most of which in some way or the other have polymer associated with them. The polymers which have different shapes, have low cost production, have been the main reason for universal uses. Bakelite is one of the commercially manufactured polymer that we have witnessed in our daily lives. Now there are some polymers we will study, that is rubber. It, you all know about the rubber. Rubber is used for making tire, elastic materials. Buna S, it is also a type of rubber that is synthetic rubber. Buna N, it is also a synthetic rubber. Buna N means butadiene nitrile. Then next polymer is Teflon. Next is trilene. This trilene is a fabric, and the same way you have heard about the polyester also, Teflon also. So these are the polymers. Now we will see the next polymer, which is based on the molecular forces. First is elastomers. These are rubber-like solids and weak interaction forces are present in them. For example, rubber. Now next is fibers. Strong, tough, high tensile strength and strong force of interaction are present. For example, nylon 6,6. Thermoplastics, these have intermediate force of attraction, for example, polyvinyl chloride. Next is thermosetting polymer. These polymers greatly improve the material's mechanical properties. It provides enhanced chemical and heat resistance, for example, phenolic epoxides, etc. Now we will come to the next, that is classification, which is based on the monomers. These are of two types, homomonomers and polymers or heteromonomers. Now homomonomers, in this type, a single type of monomer unit is present, for example polythene. Heteropolymer or copolymer, it is consist of different type of monomers unit. For example, here we will take nylon 6,6, and for homo means a same type, for example polythene. Now next topic is classification of polymer based on the structure of monomer chain. Now, first is linear. The structure of polymers containing long and straight chain falls into this category. For example, I have taken PVC. Full form of PVC is polyvinyl chloride. It is largely used for making pipes and electric cables, and these are the example of linear polymers. Now comes to next, that is branch chain polymer. When linear chain of polymer form branches, then such polymers are categorized in on branch chain polymer. For example, low density polythene. It is also called LDP. Now next is cross-linked polymers. They are composed of bifunctional, trifunctional monomer. They have stronger covalent bond in comparison to other linear polymer. Bakelite is the best example of cross-linked polymers. Now comes to the next classification, which is based on the origin. You all know about the origin, that is natural, semi-synthetic and synthetic. Now we will first discuss about the natural polymers. They occur naturally and are found in plants and animals. For example, protein, starch, cellulose, rubber. To add up, we also have been biodegradable polymers called a biopolymers. Now comes to next, that is semi-synthetic polymers. They are derived from naturally occurring polymers and undergo further chemical modification. For example, cellulose acetate. And last is synthetic, that is man-made or human-made polymers. Plastic is the best example, and you have heard about the plastics. Now we will move forward towards the next topic, that is very important, difference between addition and condensation polymers. I have already discussed about this addition and condensation polymerization. Addition means repeated, all the time the polymerization process is repeating and no byproduct is formed, but in condensation there is a byproduct is formed. Okay, now in next example or next point, we will discuss about addition. Monomer, which could be more having a functional group, or in condensation monomers should have polyfunctional. These are the differences. Now comes to next topic, that is vulcanization. Now this vulcanization process is very important process. Now in vulcanization, what happens? The raw rubber actually having so many drawbacks are there while using. So we have improved these drawbacks by adding the sulfur in the rubber. So there is a reaction